114 over 7 will be equal to, maybe to make things easier, you can calculate 7. Yeah, you have to find 7 times what? What is the maximum divisions of 114 such that the number is a good number? Okay, so you start from maybe 7 times 10 is 70, so it's still not exceeding 114. Therefore, you can continue the process. Yeah, 77, 84, and then 91, 98. Yeah, 98, and then 98 plus 7 makes 105,
Hmm.
105, and 112 in the end. More than that, it will exceed the number in the top. So 112 is 7 times what is it? 17, 16. Yeah.
Hmm.
So that's just the same as 16 plus the remainder of the division. 112 is 114 minus 112 is 2 over 7.
There's a 114 divided by 7, right?
What is it, Bex?
It's 114 divided 7. So is there a time where 7 times something equals 100?
Yeah,
Or
okay.
something close to it?
Something close to it, yes.
Really close to it.
Well, of course, you can do the other tricks, right? So, if you want to do it the long way, the 114 divided by 7 like this, right? So this is just the same as you find uh, division. You try to divide 11 with the nearest 7. Yeah, the nearest 7. Kelipatan dari 7, ya. So the
Yeah.
nearest multiplier of the 7 is 7 itself, right? So this is 1, 7, and then you minus the 11 with 7, which is what left is 4, and 4 with 4, yeah, you get the 4 down here, and then the 4 to 4. What is the nearest multiplier of 7, which close to 44? Below 44, yeah, of course. What is it, Max?
Below 44. So
Yes, the
14.
multiply.
14 plus 14. 14 plus 14 is 28. 28 plus
28,
28. 28 plus
56,
28. Wait,
56,
28 plus
right?
28. Wait. 14. 14. This is 28. 28 plus 28. 8 plus 8 is 16. 20 plus 20 is 40. 40 plus 16, 56. 56. So that means just remove 7 from that, it will become 40. But it will be 49. So one more
Yes,
7, and it should be
yes,
43.
yes.
So that this, this, this is 43. It's 6.
6, yeah. So
Out of
7
6 at the
times
top.
6. This is 6, right? So you write 6. And what is 7 times 6, Max? 42, right?
43. Oh
40.
wait, 40, 42. 43, or is it 42?
So 7, 14, 21, 28, 35, and then 35 plus 7, which is,
7.
yeah, 7, 42. Right? So this
Oh
is
yeah.
42, okay, and then this is 2. Now, the remainder is, it's not 0, right? So somehow we have to continue this division. And of course, we have learned previously that we can add 0 here, but at cost that we have to add comma here, the
0.
comma, yeah.
or
Oh, we
zero.
don't add the zero. Yeah, we add zero if the we add zero
Wait, isn't
if
the comma on the wrong direction?
oh, what is it supposed to be then? Like
The
this?
comma is on the right.
Like this?
It's supposed to be on the right. No, I mean on the left.
Like here? Like this?
So it's 0.16.
0 point?
No, on the left. On the left.
Right here? Right
No,
here?
on the left. At the very left. Yeah. No,
Oh,
no, at
okay.
the very
Oh,
left.
like this?
Yes. 0.16,
Oh,
right? Like that.
oh. We do that if we borrow zero at the beginning. We borrow zero after we do some sequence, right?
Oh, but we're not.
After we do some reduction, yeah, we subtract and so on, and then we have to land zero at the middle, right? Now the comma will come out after we do the subtractions, after we do the subtraction, if that's the case for these questions. Yeah. In the other hand, if we land zero at the beginning, which might be like 6, we divide by 7. Of course, we have to land zero at the very beginning, right? Because
Yes.
uh, there are no multiplications of 7 that are below 6. Yeah. So somehow we
Yes.
have to make this in the inside has to be more than 7. Therefore, we have to land another zero. We have to land a zero, but with cost that we have to add a zero at the beginning, 0 point something. Yeah. Okay. But this is
Okay.
we land the zero. Yeah. Okay. So you have understand, yeah? Understand, yeah? Okay. So we have 20. So the nearest multiplication of 7 that below 20 will be
Below
20.
20. 7.
Will be 2, right? Because 7 times 2 is 14, and if you try to add another 7, which is 7 times 3, 21.
22.
Hmm?
And 20.
14 plus 7
Hmm?
bags. 14 plus 7 will be 21 bags, not 22. Okay, 21. Okay, so because 21 is more than 20, so we have to, the maximum multiplication will be 4. I'm sorry, 2, which is 7 times 2. Yeah, and this will become 6, and then if we do it again, 60, the nearest will be 8. Yeah, because if you try 7 times 8, it will be 56, and if you try 7 times 9, which is 63, it will be more than 60. So this will become 56. Yeah, so you can do this process all and on, but yeah, the result will be 16.28.
Isn't this
Yeah.
like pi?
What is it?
Isn't this like pi?
Well, pi is 3.14 and so forth. I don't really remember
It
the
goes on
exact one.
forever.
Yeah,
If
it
it
will.
goes on forever,
Yeah.
then how can you add it up?
Well, there's something that we call approximations. Approximations is not the exact number. It's not the real representations of the number, but it is near that number. It is close. The value will close to
Wait,
that
wait, wait,
number.
wait, 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 wait.
That's
How does
what
that
we
make
call pi.
sense? Because,
Pi
like
is
for example, in science, to calculate volume and something, you need to
mhm.
add, like for example, written to for the circumference.
Yes,
You
yes,
need
yes.
to
You have to use
have,
pi.
if I remember, radius
Yes,
times
radius.
times 2 plus pi.
Oh,
How does
this
it
is
work
this
then?
is for the area or the circumference.
Circumference.
The circumference will be 2 times pi times r.
How do you
Okay.
do that if pi goes on
Okay.
forever?
Good question. Good question. Okay. So you have to know there's something that we
Wait for a
call.
second. Wait for a second, sorry.
Okay. Okay. Aman.
Makanan? Okay. Udah, ada? Udah. Bilang makasih. Kunci pintunya. Udah nyampe makanannya, Mama. Gaduh.
That Bex that.
Dan
Okay. Okay.
set
So this question,
sets.
yeah, this is kind of an interesting question that you asked. How the as I said earlier, pi cannot be represented with an exact number, right? With the number that we know, yeah. So it is go on and on, yeah. It's never ending. It is never ending. So 3.14 and so forth. So how can we can do an operation with it? We can do an operation or plus. How can we do pi, for example, pi plus one, right? So what will be the final number of that operation then? Okay, so well, you have to know first the concept, the type of number, or I would mathematician would usually recall it as a sets of number. So have you heard about sets?
Yes.
Have you heard? Yeah, sets is a collection, right? Collection of something. Yeah. So a set of a car, yeah, it will contain several type of car, right? Maybe an
Yeah.
electric vehicle car, a solar car, a diesel car. So it is type of car. So it cannot be mixed with other things. Yeah, it has to be the same types. For example, if I mix a book with a car, it will be, and you call it sets of car. It will be invalid then. Yeah, because we name the sets. The sets has to be contain a car. Has to contain a car. Has to contain cars in it. So you cannot insert a book to a collection of car. Okay, so just the same as the set of number. Okay, so there are type of number. Okay, I think I have teach you about this. The first one is what we call as a natural numbers. Remember what is natural numbers, Bex?
Yes.
Yeah, what is natural number then? This is the symbol, right? This is the symbol for natural number. So if I write this, it that means what I mean is the collections of natural numbers. What is natural number, Max?
Natural numbers, if I remember, is like 1, 2,
Oh,
3,
okay, good.
4, 5.
Yeah, and so on, right? Is zero also in natural numbers?
Hmm.
No, no,
No.
yes, no,
Because you need to do something to it
yes,
for
yes,
it to
yes.
become that.
So after natural numbers is the oldest kind of number that we knew. Yeah, because natural numbers, if I'm not mistaken, the Egyptian himself has,
Egyptians invented it.
yeah, yeah, yeah. Inventing it, maybe
Oh,
not.
no, no,
Yeah,
not invented.
not inventing it
They
because
didn't invent it.
the
Because the
system.
one who invented numbers is still kind of unknown, right?
Yeah, unknown. some say that the number that we know now is from Arab, or maybe from India, the number system that we know right now. Yeah, so it's still a debate, but most of the arguments say that one from India, one from Arab, from Muslim world, from Muslim era. Okay, but the Egyptian itself has a numbering system which are similar. I would say similar with the number that we had right
Not the
now.
same though.
Yeah, but not the same. Yeah, they didn't know about one, two, three. No, but they did it in their own systems of
Wait,
numbers. Okay,
and we even have it our own number system.
what is it?
If I remember, we also have our own number system.
Oh, what is it, Bex?
I forgot what the name was.
What? Who do you mean we?
From tables,
Oh, from
wooden
oh,
tables, but not literal tables, but
yeah,
it's
yeah.
named tables
What
because
tables
it's
is
how
it?
you use the count. But it's not like
Oh,
one, two, three, four, five, six, seven, eight. It's like
oh, yeah, yeah, yeah. Sempoa. Have you heard about it? Sempoa.
yeah, yeah.
Ah,
If I remember, it's a plot.
that's the way. That's not the number system actually. That's the way to calculate numbers. Yeah, they usually learn Sempoa because the effectiveness of the method to calculate big numbers. I have one friend who learned Sempoa when they're little, and yeah, they can calculate huge number in such a short time, which I cannot do. Yeah, because I'm not really
What
specialized
huge
on.
number? What huge number?
Yeah, uh maybe for example 100,295 times what 10,202,597, and then they can multiply it and give the result in such maybe 1 second or 2 seconds.
How?
I don't know, I haven't learned the method yet. But for me, counting fast is not really the it's not
Necessary
really
currently.
yes. It's not really necessary. It's maybe you appear smart to your peers. Yeah, I can guarantee that. I can guarantee that. Of course, you will be known as the human calculator. But I think without a robust concept of mathematics itself, counting fast won't be a thing. Yeah. So I did not I do not really what is it emphasize you to count fast. Yeah, but as long as you remember the steps, I think it will be it's already done lah, I think. Yeah, because counting fast, it's only appear, what is it, only appear complex, but really the process is just repeating itself, right? Because multiplying is just adding, is just like adding numbers all and all over and over again, right? But the
But
concept
more.
is, yeah, but the concept is still the same, right? It's still the same.
Yeah.
Yeah, okay, you can but if you do not have the concepts for maybe trigonometry, if have you ever heard about trigonometry?
Yes. But heard
Ah,
of, not
okay.
know of.
Heard of. Okay, trigonometry is just the way to, well, you learn about triangle, right?
Yes.
Yeah, and you know that a triangle has an angle, right?
Yes, there's three
Yeah,
angles.
yeah, it has three angles. Now the
Triangle.
yeah, okay, but trigonometry is basically just the art of finding the angle by knowing the sides of the length of each of the triangle. Yeah, because triangle has a side, right? Three sides. Okay, it can be the same, it can be different each other. Yeah, it can also be two of them the same, the others don't. Yeah, it can be like that. Yeah. But trigonometry, well, you'll learn about it later, yeah. It's not really necessary for you right now, okay? Okay, back to our topics, yeah. Natural numbers, okay? And then uh we had what we called as, what is it, Bex? After all natural numbers, we have what, Bex?
Negative numbers.
Yeah, which are, we called it as in a,
Negative.
yeah. So negative number plus zero and plus positive number will be, what is it called,
Wait,
Bex?
what?
So if I have, you said that you have a negative number, right? Negative number. And
Yeah.
then if I have negative number and then zero and then positive number, which are, positive number is basically a natural number, right? If I add all of those to one sets, it will become what, Bex? What is that called, Bex? Now, if you
Integer.
recognize integers, good. Yeah, integers. So integer numbers. So the sign will be like this. This is integers. So integers is a collections of start from zero, of course. Then you have one, two, three, four, five, and then minus one, minus two, minus three, and so on. Yeah, so this is what we call as an integer number. And by the way, the from the history itself, natural numbers and integers has a long way to get from, that's there's a long process before people know what is integers. Yeah, because uh, I think if I'm not mistaken, the Pythagoras. Have you heard about Pythagoras?
The what?
Pythagoras.
Pythagoras.
Pythagor.
The
Yeah.
Pythagoras, right?
Have you have yes? Have ever heard about Pythagorean theorem? A squared plus b squared is equal to c squared.
Nah.
Ah, okay. Yeah, I think you'll learn about it later. Yeah, it is a geometry. Okay, so if the that's what we call as a Pythagorean theorem. So if I had a triangle, let me draw a triangle. So if I have a triangle like this, and then this sides is 90-degree. Okay, so let's call this A. The length of this side is A, and then this is also B. This is B, and this side is C. The length of it, based on Pythagorean theorem, Pythagorean Pythagoras, yeah, Pythagoras theorem. It say that the square of the A, the plus the square of the B, it will be equal to the square of the C. Okay, so this is Pythagorean theorem. Now, Pythagoras is a mathematician in 500 BC, if I'm not mistaken. BC lah intinya,
Oh, he's
before Christ.
Egyptian.
Oh, no, 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 no. Later than Egyptian is like 1000 before Christ, right? BC, more longer than Pythagorean
BC.
theorem, before Christ. Yeah. So, just so if I'm not mistaken, the Pythagoras itself, this is the fundamental theorem in mathematics. Uh, and this is one of the first theorem established in mathematics. Okay, so this is fundamental, and you will learn it later, like, yeah. So this
Wait,
is integer
theorem means
numbers.
theory.
What is it?
Theorem means theory.
Theorem is have you heard about theorem in mathematics?
Yes, kind of.
Ah, yeah. So theorem itself, it's a formula. Yeah, well, you can say it as a formula. So
A way to
in
make stuff. do stuff.
Yeah, you can
Eh,
also say it like this. So theorem itself, it's a what is it, mathematical expression which are say about something, yeah, say about something, and it is also true for all conditions. Yeah, so the Pythagoras theorem say that if I have a triangle which sides is 90 degree, so this is 90 degree, this is the symbol. If I have those, then the theorem, the formula will work. Otherwise, it won't work. Okay, so if I don't have a right side triangle, 90 degree triangle, therefore this theorem won't work. The formula won't work. So that's a theorem. Okay. Now, after the integer numbers, we also have what we call as, what is it, Bex? You have what we call
hmm.
as, so there's another thing that we call as a fractional numbers.
Um,
Fractional numbers. Okay. So
fractional number.
fraction. So fractional numbers, the symbol will be like this, kind of. Yeah, this is fraction, or fraction number is 1 over 2. This is fraction, right? Or maybe 2 over 4, 3 over 6. Yeah, this is fraction numbers. Yeah. So fractional numbers will be like this. So will be defined as P over Q. So any P over Q, which with GCD is, the maximum GCD is equal to 1. So this is the fractional numbers, okay? 1 over 2, 2 over 3, 3 over 4, yeah? So this is fractional numbers. Now, so you this is maybe common lah, yeah, for you, yeah? And then we have what we call as real number. Real
Oh.
numbers. Real
Wait,
number.
does that mean everything? Wait, does that mean nothing is real? None of the numbers?
Everything is real number. So real number is just see, this is the R. Real number is just you add, yeah. So real number by definition is just irrational fraction numbers plus integers plus natural
So that means
numbers.
pi isn't real?
Nah, here's the thing. So real number is fractional number plus integer plus natural number, and also irrational numbers. Now irrational number is quite a unique number. So it's a number that represented cannot be represent using uh number using using sets of number that we had. So previously we had q. Q is rational numbers. Rational, yeah, that's the term that I try to find. Rational number. Yeah, rational numbers. We cannot represent it with a rational number. Yeah, of course. Uh, you cannot represent pi with numbers, with rational numbers. You cannot also represent it with integers. You cannot also represent with the natural numbers. Yeah. So it's a quite of a mystery.
Wait, now because you said that,
Yeah.
what the, how can one be represented as other than what we currently see it as?
What is it, Bex?
How do we represent one other than just the drawing of one and one item?
In fractional numbers, 1/1 is 1, right? That's the other representation for
No,
1
without
itself.
drawings or physical items. How can
Uh,
we
how can you? Well, you can represent it with a dot. If you have one dot, that means one. If you have two dots, that means two. So
but
there's a
that's
lot of
technically a drawing, right?
yeah, yeah. Well, that's here's the thing. Uh, Number itself is a consensus. So you can represent one with a lot of things, yeah. But the consensus or the agreement that the mathematician had to represent a thing in numerical way is using these symbols. Of course, yeah, of course, if you move to other region, maybe yeah, there's also another way to number things. Yeah. So
Like, what's the name?
have you ever heard
E
about Arabic? Ever heard
Yo
about Arab?
Chi Ba Yo Shi.
Yeah, that's in Mandarin. Yeah. I learned a little bit about Arabic. Yeah. So Arabic represent one with this. This is one. This is two, if
Uh,
I'm not mistaken. This is three.
Live Batan.
Uh, Alif bata. Yeah. That's word. Yeah. That's not number. This is yeah. I learned a little bit. This is Arabic numbering system. This is Arabic numbering system. Yeah.
Did you
But
know
in
that the number 9 looks like a 9?
well. I think there's also
It's
one thing.
true.
Yeah. Yeah, 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 yeah. Nine is looks like a nine. Yeah, of course not. But there's also I won't say that this is uh a valid fact. Yeah, but I think for fun this is quite a good information. Yeah. So there's why does one looks like this? Okay, why does one look like this? Because yeah, this is only for fun. Yeah, this is only for fun. Some say that it because this figure, this shape only have one side, only have one angle. If I gave you two will be like this. Yeah, so two will be like this, right? Maybe I'm gonna draw it like this. Okay, two will be. Wait. Two like this. Maybe I'm not really good at drawing it. So this is two. Well, two have two sides. These sides. I'm sorry, not sides. Angle. This is two angle. Two angles.
How
If you
many
draw
angles
three,
does 2 have?
what is it?
How many angles? Wait,
Yeah. So
3 has more than 3 angles.
yeah. So yeah, it's not really that true. Yeah, it's not really true. Yeah, as I said, this is only for fun. I think if you try
It
to draw it in
the
digital
only
shape,
I think the only reason they use those are because it's a simple way to write it without any
yeah, yeah. If you have
and
ever,
it's noticeable. Like, for
yeah.
example, if you put that from a far away, you can easily see it and the difference
Yeah.
of it.
Well, yeah, it can be like that. Yeah. Yeah. Well, of course, the numbering system is created so that we can do calculation and can do numerical analysis with a much more efficient way, right? Because if you ever see the numerical system for Egyptian era, they literally draw to represent I don't if I'm not mistaken 50. They draw a tree to represent 100 if I'm not mistaken. Yeah. So it's quite a quite a complicated numbering system. Yeah, that's why we use this simple. Well, relatively to us, that's a more simple way to represent a number. Yeah. Okay. So back to our topic again. So pi cannot be represented with a number. So pi is not equal to 1.14. This is false. This is not true. Yeah, because pi, if you want to make it equal, so pi is equal to 3.14 and so forth. This is true if you draw it like if you say it like this. The this what we call, the mathematician called it as an approximation. So approximation itself, it's well, because pi cannot be represented with something exact, we use number that close to that pi, yeah, to make some calculation, to make thing easier. So pi, if you
So
call
that
it as,
means
if you draw it like this is the symbol
that
for approximation. This is the symbol of approximate. So if you call it pi is close to 3.14, this is true. Or maybe you can call it as uh, 22 over 7. Ever heard about that? Those approximation? 22 over 7? Bex? Ever heard that? 22 over 7? Bex? Yeah, this is the approximation. This is not
no.
the exact value. Yeah, this is true for
Oh,
this.
so we've never been adding with pi.
Yeah, yeah. That's the bitter truth. Yeah. So if your teacher say that pi is equal to 3.4, well, what they mean actually is pi is close to 314. Yeah. The exact value we don't really know.
So that means, wait, I'm confused now. Because you said that, I when they only write pi, are they
Yes.
referring pi as 3.14, 3.142, 3.14 da 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 da,
Oh,
or
yeah.
almost the whole entire thing?
So they usually, yeah, in the formal way, they represent, if they say that 100 pi maybe, that means they calculating 100 times 3.14 and so forth, not 3.14. Now, because the number itself cannot be simplified more, usually when they write 100 times pi, the final number will be just 100 times pi. So yeah, because you cannot represent the pi itself with a good number, with a decimal number, you just use pi as a pi. It's the most simplest way to, well, I would say that pi itself is the most perfect way to represent a pi. So don't change it to other number, because other number won't be equal. It's just close to. Okay?
So pi isn't a number.
Pi is a number. Again, irrational number. That's the 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 eerie
Rational
thing about,
number.
yeah, irrational number. A number that cannot be represented using number that we had. We cannot represent it with the integers. We cannot
So that
represent it with the
means,
fractionals.
if you say that, does that
Yes.
mean infinity is an irrational number?
Infinity. Ah, okay, okay. It's a good topic. That's a good question. Okay, that's a good question. Infinity, it's now
You've
pi.
always said that.
Yeah, okay, okay, okay. Here's the thing. We can call pi as a number because it obeyed the rule that we already had in the first place. Okay? So of course, yeah. So if I had pi plus pi, this is will become 2 pi. Yeah, this is just the same as x plus x is equal to 2x, right? right, Bex? Agree, yeah? Pi plus
Yes.
pi is just 2 pi, okay? Don't change it. By the way, don't change it to 2 times 314. Yeah, this is false. False. Because this is not equal. This is only close to, yeah. If you want to write this, it means that 2 pi is close to 2 times 3.14. Okay? So the the operations of pi is obeying our rule, our multiplication rule, our what is it? Our plus rule, our minus rule. Yeah. So if I pi minus pi, this is equal to 0, right? This is equal to 0, right, Bex? Because
Yes.
you 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 add pi, you have pi, and then you subtract it with pi, of course. The remainder will be 0.
It's like 1 minus 1.
Yeah, so the pi, yeah, in conclusion, pi it's is a number. Is a number because it still obey the rule.
Oh, I understand. I understand. Because
That we
the
had.
infinite number in pi isn't infinite numbers of normal numbers, it's an
Yeah,
infinite numbers of fractional numbers.
yeah.
Because in
So
infinity, it's infinite everywhere.
yeah. Well,
So
think
that
of it like
means
this.
you
Think of
cannot
it like
add
this,
it,
Bex.
you cannot subtract it, you cannot do
Yeah.
anything to it.
Yes, that's
It
the
must
thing.
keep
Yeah, yeah. Okay.
staying 100, one infinity.
Yeah, good. Another example is pi infinity plus infinity. If we just just assume that we can do plus with infinity. So infinity plus infinity will become just infinity, right? There's no such thing as 2 infinity, right? Agree, Bex?
Yeah. Yes.
That means I can subtract both sides with negative with infinity, right? So infinity plus infinity minus infinity, and then the right side infinity. Yeah, right, Bex? Therefore, infinity minus infinity has to be 0, right? If we assume that it is a number,
Yes.
if we assume. Therefore, infinity equal to infinity minus
But
infinity, 0.
infinity is infinity. So that means it's an endless number if it was a number.
Yeah.
But if you were to
Or,
subtract infinity with infinity, will it be zero or will
yeah,
it
that's the
be
question, right?
infinity?
That's
Because
the question, right?
infinity is forever. But forever minus
We don't
forever
know the
is
limit
not
for
really a
forever,
thing.
right? It's not really a thing. Yeah, that's the problem. That's the problem. That's why, that's why Yeah, so if you see from this equation only, that means infinity is equal to 0, which are obviously wrong, right? Infinity equal to 0 doesn't make any sense. That's why infinity is a concept. It's only a concept. A concept.
It's a concept
Yeah, the
of a
concept of
number,
a
but
number
it
that
isn't a number.
yeah, that isn't a number. Infinity is just a concept of endless thing, endless things. So
Like what Leonardo did, like what Leonardo da Vinci always does. He makes
yeah,
multiple concepts, but he can't
yes.
make it.
Yes. Pi itself, you can also say that pi has infinite number of uh to represent a pi, yeah. This is endless thing, right? 3.14 and so forth, right? So this is to represent a pi, we need infinite number of numbers, yeah, of integers. So this is infinity number. But of course, we still doesn't know yet is pi really really an irrational number or not? Yeah, so it's still on the search. Yeah, but we assume that we cannot represent a pi with natural numbers. Yeah, so pi is just a pi. That's what we call as a as an irrational number. Other irrational number, there's also what we call as I. I. I is it stands for Euler number. Ever heard about Euler? Bex? Euler. Ever heard about Euler number, Bex?
Euler.
Euler.
That's not so. Euler. Euro.
Yeah, but
Euler.
it's not really an English. Yeah, he's not in
Oil.
English. He's not English. He's not an English.
It's
This
not
is not an
English.
English. He's not an Englishman. He's not an English.
Oh,
He's he's not from English. If I'm not mistaken, Euler is
is it
from
German?
German. Yeah, that's why the pronunciation kind of different. Yeah, let me search it up for you. Euler.
But German
Euler.
also uses Latin.
Yeah.
But German
Oh,
also uses Latin and is mostly based on
yeah,
American. I mean,
but they had
British.
different pronunciation, right? They had different pronunciation.
Just with a
Oh,
J.
yeah, that's language. Yeah,
And
that's how language works.
and
By
that
the way,
one letter that looks like a B that goes S.
yeah, yeah, yeah. That's how language works.
What do you mean by the way?
By the way, he's from Switzerland. Switzerland. Ole,
Switzerland.
yeah, his full name is Leonhard Euler. Leonhard Euler. I don't know how to
Leonhard.
I don't know how to pronounce it in
Leon.
Switzerland.
Leon.
Leon. It's in English. I don't know. Maybe
Leonhard.
different pronunciation in Switzerland. Yeah. This is Euler. This is Euler. This is
Euler.
Euler. Euler. Euler. Max.
Euler.
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 Hey, Euler.
No, no, different. Different. Euler is snake. So Euler number is also Euler number is also
That's his Euler.
Euler. Well, some might say Euler, some might say Euler. That's just this different pronunciation. Okay, Euler
Euler.
number, Euler. I don't know. It sounds more demure with Euler rather than
It's
Euler.
it's Euler. Euler.
Euler.
It's not Euler. It's Euler.
Euler. I prefer to
In
say it as
Switzerland,
Euler.
Switzerland. I think it's
I prefer
Euler.
to say it Euler. Euler number. It
Euler.
sounds more. It sounds more elegant.
Euler.
Elegant. Okay. So Euler number is also
It's not Euler. It's Euler
Euler.
with the Y sound.
Euler.
You're American now. You love oil.
Okay. This number is also irrational number. Yeah. Because
Yes.
of course, the same reason as pi. I is I. This is I, right? I. If I'm not mistaken, the first three digits is
No, it's
2.13. I. This is I. The symbol is I. The symbol.
I.
The symbol is I. Okay, just call it I for now. Okay, I. I is equal to 2.13 and so on. Okay,
My.
so we have pi, which is 3.14 and so on. Yeah. There's also irrational number.
How did you?
No.
Wait. How did they get all of these irrational numbers?
Wow. It's quite another. That's a story for another time. That's a story for another time.
How?
It's quite a
Wait,
long thing.
is that like a something like times something times 10
No,
10
it's
10
not
10
really that
10?
simple. It's not really that simple. It's quite a
I know
advanced
it
thing.
goes like it might be something goes like from here to the bottom of the Mariana Trench.
Not that deep, but yeah, it's quite a well. You need to learn more thing before you get to that concepts. Okay, okay. And when I
Look at that
mean
guy.
more thing,
Even he's convinced that he can do something.
pi. Okay, the concept of pi comes from circle.
Circle.
Yeah, circle.
Oh, because circle has infinite sides.
Oh yeah, yeah. Oh yeah. That's a good intuition. Yes. Yeah, because people in the maybe before we know the formula for a circle, which is pi r square or pi the area, yeah, for the area, pi r square or yeah, they use approximation to approximate the number, the area of a circle by drawing a polygon. Have you heard about polygon, Bex?
Polygon donut
Polygon. Okay, polygon. A triangle is a
is
polygon. A three-side
a
polygon.
donut.
No, 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 no. Polygon is a triangle is a polygon. A three-side polygon. A rectangle is a four-side polygon. So, a polygon
Polygon
is
is everything.
yeah, almost everything. Yeah. So,
90
people.
degree
Yeah, you can say it like that. So a
is
circle. Yeah.
donut a polygon?
No, donut is not a polygon. Well, let me think. It's a polygon with infinite side.
More sides than a circle.
Eh, well, donut itself is a circle, right? Basically a circle.
It's two, three circles actually.
Well, a circle inside a circle. You can say it like that, right? So people before we know the that people in the past, yeah, to approximate
Yeah.
the area of a circle, they use a polygon. So they drew up
Yeah.
like this. This is a polygon. So first
That's a
they
polygon.
this is the first approximation. This is a triangle, which is a three-side
Triangle.
polygon, and then we had four-side polygon,
Fours.
which
So
is
they
a
were just
rectangle.
trying to guess the area of a circle
By
using
using this,
squares.
yeah. But the approximation gets better if you, for example, if you had nine side of polygon, it will be like this. Nine side will be well, we start from five side. Yeah, five side will be like this. You see that the approximation it get better, right? So first one we got like here, but still many area that doesn't covered by the polygon. The four side it gets better. The five side it gets better. Yeah. So
But does that
uh
mean there's 3.14 sides?
the side will be infinity. The side will be infinity. To approximate goes to infinity. Goes to infinity. Okay. To make it equal. To make it equal to the circle, we have to draw infinity side polygon. Well, that's the thing that you will learn in calculus, yeah? The concept of infinity, you will learn it in calculus. But this is just a little bit of an information, yeah, that people before we know the equation for pi r square, they use this polygon to approximate circles. Okay? Now, pi itself comes from the question of the question in how to calculate the circumference of a uh, of a circle. They noticed that the they noticed that the ratio between uh, the circumference of a rectangle of a circle divided by ratio between the circumference with the diameter of the polygon. I'm sorry, of the circles is always pi. Is always pi. So it comes from the question on how to find and on how to find the ratio between the circumference, which is k, and d with the diameter, and they found that the ratio is always pi. Of course, they didn't directly find that the ratio is equal to pi, but after some research and
Okay.
process of thought, yeah, they find that the ratio is
How
equal to
did
pi.
they find Wait, how did they find out that everything was equal to pi? Do they go like
Yeah,
dun 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 for a long time
yeah,
on this
yeah.
one thing
So well, it's a long
until it
analysis that.
almost goes?
Namanya research, guys. Mereka lakukan berulang-ulang sampai beneran dapat.
Wait, so wait. For example, this is they were doing this number and this number, divide
Yeah.
it out, and then
Yes.
they're gonna divide it until almost a long thing that
Yeah. So
resembles pi. But what happens if almost at the end it is different than pi?
No,
so the
that's why the
so
result
the
is fine.
so the method, yeah. So the method there. So they try various types of circles, yeah. So they try circle with circumference maybe 100, yeah. So and then they measure the diameter with a ruler, and then they try to divide the circumference with the diameter. For all cases, they found that the the ratio between them will always be pi. So after those million times of trying with various types of circles, yeah, with big circles, with small circles, the ratio will always be pi, which is fascinating. Which is fascinating. Yeah, because how can someone guess that with how don't no matter how big, the circle is, the ratio will always be pi. Who will guess it at that time? Yeah. So that's the beauty of math. Yeah. There's always be a consistency on it. Okay.
Ngapain liatin ke sini, Bex? Fokus.
Okay, Max. Okay, so we learn a lot of new thing, yeah, right now. And for now, yeah, we learn about sets of number and then the history of math, yeah. So, yeah, I think that's that's a good topic for today. Yeah? I think we learned about the history of math, how how we find numbers, yeah, from Arabic numbers, yeah, and then we had the number that we had today, yeah, okay, and then we learn about irrational number, which is, by the way, kind of abstract thing, yeah, to learn, yeah, for elementary school, yeah, because usually teachers in elementary school skip this part, skip the part where pi is in irrational numbers, yeah. So it's a good thing that you learned it from now. Yeah, because our teacher usually say in Indonesia, yeah, particularly pi is equal to 3.14, which I find later on throughout my studies that, oh, no, pi is not equal to 3.14, it's only an approximation. Okay, okay, Bex, I think that's enough for our discussion for today. I think that's already heavy discussion for us, yeah, for today, yeah. By the way, did you have any homework for today? Did you have any
No.
homework for today? Okay, okay. If you have any question, just reach me out, okay? As always, I'm gonna share the recording. Yeah, I'm gonna share the recording with you and also the notes that we took for today, okay? Before we end our session today, is there any question that you want to ask? Nothing, yeah? Oh, yeah?
Next, is there anything you want to ask?
Anything to ask, maybe?
No.
Oh, yeah? Okay. Okay, if you have any question, you can reach me out in my WhatsApp, okay? Okay, bye-bye.
Okay.
Okay, bye bye
Bye
bye.
bye. Thank you.
Bye
Thank
bye.
you.
Thank you. Bye bye. I'm gonna
We.
end the meeting, yeah? Have a good day.
Yes.